right, welcome to Developer Stories. This is our show and tell session. It's going to be 5-minute lightning talk style presentations from various participants in the Mapbox ecosystem, Mapbox developer community. So we've got all kinds of different projects, different use cases, different stories. It's going to be action-packed and fun, so hope you're ready for some really interesting use cases and developer stories from Mapbox, Mapbox developers. Okay, couple of housekeeping things. Each session at Build is recorded and will be available online after the fact. Captions are available in multiple languages. Just use the Show Captions button in your Zoom interface. You can submit questions through Zoom Q&A, and all the participants will also be able to monitor chat afterwards and talk to you. And then you can discover all the other build sessions we have going on in the event lobby or at mapbox.com/build. So without further ado, I want to welcome everybody, and we're going to kick it off with our very first presentation. So please welcome Marco Giuliani, Senior Software Engineer, who's going to show us NYC Monitor, visualizing citywide incidents with real-time alerts, AI-driven investigations, and interactive mapping of urban patterns. Welcome, Marco.
Hey everyone, have a look at my screen here. Yeah, so real quick, this is the current state of New York Monitor, an application to autonomously monitor alert types across the 5 boroughs of New York. It was an end-to-end system using Cloud Scheduler and various other Google services to autonomously scrape alerts and map them and allow users to interactively filter them. This is done using React Map GL, and I submitted this for a competition, which I was really excited about. It was kind of an end-to-end like agent competition. It would create reports on demand and so on and so forth. So it would assemble evidence and artifacts and stuff like that. So that was kind of like the end-to-end competition. However, the mapping side was a little could have used a lot more work, right? So I wanted to serve more alerts and faster. And for that, there was several different strategies around how to serve alerts, whether or not to stream them in, whether or not to cache them, how to render them better. And so there's a lot of room for improvement. And however, there are some usage patterns that I kept in mind here. Like when you think about this is kind of an analysis application. So the goal was to have like rich views of things, not just like truncated views of that are filtered because there's too many alerts or something like that. One of the key constraints was that you would want an overall view. You'd want the filtering and the zooming to be quick, even if the initial load was a bit longer. So in that way, those are some of the constraints, right? So serving only what's in the viewport would have led to many requests, so that was kind of not an option. And then implementing some kind of geohash to only serve like a zip code worth of alerts was also not really an option because the usage pattern of this application was to have like a global um, view as opposed to having like localized views. And then ultimately I decided to stream in alerts and only render the visible ones. So that led to a lot of improvement. So basically what I ended up implementing for this particular demo is like only serving up to 6 months worth of alerts, streaming them in, reducing the alert payload so that things are coming in faster, and only rendering kind of visible alerts on the viewport. Similarly, rendering dots um, was expensive, so I have kind of a heat map implementation that renders a lot faster based on the clustering of the alerts. And so there's an automatic switch to that, um, which makes it more performant. And so here's the quick demo. Start a video, and I have it sped up at a little bit because despite some of these optimizations, it still takes about a minute to load 50,000 alerts. And so there's some things I can do to improve there, but at this time, the way this works is it's streaming in the alerts, and you can interact with the map in the meantime. As you can see, you can switch over to dot mode, but after a certain threshold, it automatically switches back to kind of heat map. And so all of this is just done to make the app less janky and more interactive, right? And so yeah, this is kind of, as you can see, it's taking a while to load in all of the alerts. I need to test this further and implement more optimizations, but it makes it makes for a rich view when you zoom out, when you zoom in, you can serve many more alerts in this way. So thank you very much.
All right, thank you for that. If you have questions for Marco about this awesome data-rich project for New York City, drop them in the chat. And I would love to welcome our next presenter, who is Evelyn Oma, a data engineer who's going to show us a project with the Lamo Electrification Project. Take it away, Evelyn.
All right, let me share my screen. Can you see my screen?
I see a screen that says Lamo Electrification. It's a
Yes,
slide.
yes. Yes, so I'm going to talk about the Lamo electrification project. So the purpose of this project was to plan for the green electrification of over 400 villages, and that was to mainly use AI to find the optimum position of where we can place the mini grids. Yeah, and one of the main reasons why we used Mapbox was because, first of all, it enables you to be able to customize your map style and make it your own. That is the main reason why we used it. And also another reason why we used Mapbox, it was able to handle all the data we have, because we have around 10 layers, and also the building layer really has very many features. So Mapbox was able to handle all that for us. And another reason why is because for the front end, we wanted to use Next.js, and it was able to integrate it into the system. So this is how the application looks like. So the main purpose was to make a web application whereby anyone can use it, whether a technical person, a non-technical person. So we wanted to make it very user-friendly so that someone can be able to talk around and understand what we're trying to do with the project. So that was our main purpose. So on this side, you can see the filters. The middle part is where there's map interactivity. And on the side, the person can choose the different villages, and then you know what strategy we're planning for that particular village. And this is not only at village level, we also do it at district level, at sub-county level, and also at county level. Yeah. And another reason why we're using Mapbox is because the ability to filter out features from each layer and being able to pull out a specific village, and then you can look at the analysis of that particular village at that level. So that was something very interesting, because with other platforms like Leaflet, I wouldn't be able to do that. But with Mapbox, it was very easy to integrate that. Yeah. Then on top of that, we wanted to make it possible for stakeholders. Let's say someone wants to place a mini grid somewhere, they should be able to draw like a polygon, and then we give them an analysis of that region, and then we tell them maybe how many roads are here. Is this region, is this region viable for green electrification or not? Yeah. And this is all possible because sorry, our main aim was to make the application as easy as possible for anyone to use. And with Mapbox, that's what happened, because we tried with Leaflet, it didn't work. And then when it came to Mapbox, it was very easy to integrate. Yeah. So yeah, that's mainly it. Let me do a small demo. Then, can you see my screen?
Yes, looks great.
Yeah, so as you can see here, so this is just so someone can click on a village, and then you get what is in that village. You can be able to see how many permanent buildings are here, and then you can see the position of the mini grid, and then from here you can change the radius to know how big like the area it covers. And then you also, yeah, and then you can go back to the default view. Yeah. And also another thing with Mapbox, it was quite fast. Like the loading time was really quite, it doesn't take long. And then we also wanted the possibility of someone drawing a polygon. We draw, get an analysis of if this area is feasible. And then, yeah. So yeah, I think that's it for me.
Okay,
Yeah,
thank
this
you,
is going to
Evelyn.
take some time. So yeah, thank you.
Yeah, this is wonderful. So you can check out lamo.sunbird.ai if you want to explore it on your own. And then Evelyn can answer some questions for you in the chat if you still have any. Thank you for sharing. I'm going to welcome our next guest, Robin Mills. He's going to show off a custom photo map that he created using Mapbox. Take it away, Robin.
My name is Robin Mills. I expressed this earlier without the video. I wanted to show you my beautiful garden. And I'm wanting to talk to you about geotagging photographs and sharing them on my website and to show you how I used Mapbox GL. So my website, this is a typical page in the website. Whenever we go away, I put up photographs and my family and friends can see where we've been. And if we go and look, we lived in the United States for 15 years and we've been everywhere. We've been to all 50 states and all the national parks and things. And when we put up the photographs, we can bring them up on of where the photographs were taken on Google Maps. And if we press the button, you can see the photographs will move around and show you where they were taken. Now, this is all very good, except I don't really like Google Maps very much because it uses the Mercator projection, and the world isn't square, the world is round. So let me show you how I use Mapbox when it came to thinking about searching for photographs. So if we press the search button, we can, if we can, we can type things into the search, but if we bring up the Mapbox display, you'll see the globe of the world, and there are different clusters. And if we click on a cluster like this one here, then we can see the photographs that I took in a recent trip to Rome. And we can move around the world and go to other places. But I'm going to focus on the clusters come in different colors. So red means there's thousands of photographs. We don't want to open up thousands of photographs. Yellow means there's hundreds of photographs, and blue means there's less than 100. And if we keep zooming into London, eventually we zoom in so much, I just put up all the photographs individually, and I'd like to click on a bunch of photographs that particularly interest me here, which were taken in the Pool of London. We were on a ship and we were about to sail through Tower Bridge, and here's the bridge starting to open up. And we're sailing along and we're going under Tower Pier, Tower Bridge. The bridge is closing behind us, right? And there the bridge is closed now. The bridge was open for 6 minutes, causing no end of chaos in London. Right, so what's the point of all of this? Well, if you're interested in this kind of thing, putting photographs onto a website and using Mapbox to show you where they are, then please visit clanmills.com. Thank you for listening. If you'd like to talk to me about any of this, my email address is on the website. Thank you for your attention.
All right, thank you so much, Robin. Love these creative use cases for keeping track of your own large collection of photographs. Next, I would like to welcome Ghazala Mohseni, R&D Director for Interactive OR, who's going to show us Response Pro. Come on out, Ghazala, and would love to hear what you have to share.
Hi everyone, my name is Ghazala or Gaz, and today I want to present our Response Pro. Let me share my screen. Okay, can you see my screen?
Looks great.
Okay, great. This is about fire department planning, and effective fire department planning is essential for public safety. And traditional methods for fire department planning relies on static reports. They are time consuming and you cannot make any changes and see the effects in real time actually. So fire master plans need need an interactive tool, a way to enable a continuous planning and continuous optimization. This is the aim and the goal of this Response Pro. On the background, you can see the emergency calls. Here, the emergency calls, the historical emergency calls, you can just filter them out based on the year to see the trend, or even based on the categories, or based on the platoons or time of the day, and also see how the distribution of the calls in different categories are changing, or even see that how these calls are changing based on the time of the day during these years. These are the descriptive part of the analysis. And also on the background, we have the stations, the station locations and their corresponding coverage area. These corresponding coverage area and the boundaries are customizable, and they can be edited in a way that we want to. For example, here we can just add more points to the boundary, move them, make it smaller or larger, or maybe remove some of the boundaries. And then, as I was mentioning, this is the descriptive part of the analysis. And you can see that we have the contours for the travel time for this specific station. And as I am moving this station, you can see that boundaries, the isochrones are getting updated. We can also see how the travel time based on different contours, travel times can change. For example, here we have 2, 4, 6, and 8 minutes. We can see that how each of the stations are responding based on these travel times, and we can update them. For example, make it 4, 6, 8, and 10 for all of the stations, or for each of them, to identify the coverage gap areas. This was the descriptive part. Let me introduce you to the prediction part, prediction engine. Here you can see the number of calls over the years, and this is the prediction part. This is for all of the whole system, all of the system. And we can also draw a polygon to just focus on a part of the city, see how these different calls over the years would be, and how the prediction would work for each of them. In addition to the prediction engine, we have an optimization engine, which let me introduce first let me refresh the page. Sorry, my internet connection sometimes. Okay. As you was seeing, I was able to move the stations, and give me a second because my internet, I think, died. Okay, sorry, I didn't shoot it. Okay. Here you can see that when I can move the stations. I can move a station or edit the boundaries, or I can even delete a station. For example, here I want to delete these stations. And then we have the optimization panel. For example, I want to focus on, I will show the hexagons by the background. And for example, I want to add 5 new stations based on different type categories. For example, I want to focus on all of the type of the categories, and I define a minimum coverage area of 2 kilometers. And I want to have 5 new locations, optimal location for the new stations on the areas that doesn't have any station right now. And as you can see, these stations are distributed like this. But what if I increase the minimum coverage? You can see that they are going to be expanded over the larger area. These reports and these customization, all of them can be saved and reload later to be investigated or used by another user, or we can have the reports in different formats, in geojson formats, as PDF or shapefile. We have also tested this Response Pro for the city of Toronto as a larger area, as you can see. And also I'm going to share this link which introduce more details about the Response Pro. Thank you.
Thank you so much. And yeah, hopefully that's a helpful tool for these jurisdictions when they're planning their response and fire department and safety planning. Okay, next speaker I would like to welcome out is Zach Zerbe, who's going to talk to us about Caravan. Take it away, Zach.
Hi, everyone. My name is Zach Zerbe. I'm a recent college graduate. I'm going to share my screen just a second. Today, I want to talk about my senior capstone project called Caravan. I did this. Uh, for my senior capstone project with 5 other students. We had a, a group of alumni approach us with this idea when they were driving back from school after they graduated, and they said, wouldn't it be fun if we could plan our road trips out collaboratively and then navigate through them in separate cars and stay connected, add stops together, listen to music together. And so they approached us to build this app for our capstone project. And the key point here is that we had 3.5 weeks to build this app. So that's everything you see was done in 3.5 weeks. Basically, high-level design of this app. We have all these different front-end views for the user journey, a database and a server for live location handling. And then, of course, up here at the top, we have the maps, the search, and the navigation SDK, which obviously we chose to use Mapbox for those SDKs. And the key reasons were they had a vast set of development tools, a really good set of documentation, and we had the ability to tinker at small scale and develop this for free, which was nice and was not available with Google. So I do not have a live demo right now because our server and database have not been up for many months, but I can show you a little bit about some of our core features. So seeing the group members' live location on the navigation screen as you're navigating with the active guidance navigation was really important for us. This feature was something that I worked on heavily, and it really showed the robustness and intuitiveness of Mapbox. The navigation view controller allowed me to customize this UI a little bit to fit our model. The directions API was super intuitive, allowed us to have automatic route generation. And then, of course, my favorite was the Mapbox search, adding stops dynamically along your route. There was a lot of different ways that you could figure out, okay, how far ahead do I want to search? Where do I want to search along the route? How many minutes of extra time do we want to add if we're adding stops? And then the point annotation manager from Mapbox Maps allowed us to integrate that live location data. And then we also have the trip planning collaboratively with group members, and that also heavily implemented Mapbox Maps, panning and zooming features to explore different places, different points of interest, and the search was also integrated with this feature. So I'm just going to show a quick video.
Can't see him because he's out of view. Oh, we'll cross paths again. Okay. I'm like holding a laptop. I'm like,
Arrive south on
all the
North River Street
API
for
requests
West.
in the backseat. We can see him. We can see him on the other. Oh wait, we have to pass him and like see his car. Yes. That's it.
In 500
Yeah,
feet,
yeah.
turn left onto North Nevada Avenue.
Okay, well that was our like big proof of concept moment for our project. We were really excited about that happening. There's a lot of future work to be done. I'm sorry I couldn't give you guys a better demo today, but I'm really excited about the possibility of looking into more advanced route planning. Mapbox has tons of geospatial data, and I would love to dive deeper into Mapbox search to really customize routes based on any number of parameters that we're using. But yeah, I think that the key takeaway for this was we had 3.5 weeks to implement it. And Mapbox made that possible. I mean, we were able to dive in right away, get maps up and running, get the navigation turn by turn going, within a week and a half, and then, allowing the customizability to integrate with our live location sharing and things like this were really easy to use for Mapbox. So thank you for listening. This was a fun presentation. Please reach out to this email if you have any questions, and I can put you into contact with our clients whose idea this was originally. So thank you.
Awesome. Thank you so much for that. Great to see some mobile apps represented in the show and tells. Great to see combination of nav search and maps all in one project. And yeah, if you have any more questions for Zach, go ahead and ask them in the chat. Next, I would like to call out Javier, who's going to show us GeoPOIs. Take it away, Javier.
Hi, my name is Javier, founder of GeoPOIs. I'm from Spain. Okay, 1 second. Okay, can you see my screen? Right. This is a Mapbox boilerplate. It's a Next.js demo for advanced web mapping application, right? This is the demo. This is a starter template for Mapbox projects. The URL is geopois.app. It's open. You need only the Mapbox token. Okay. The stack is Next.js, is a React framework, Material UI, Redux Toolkit, Firebase, and of course, Mapbox. The goal is simple. Start fast, build faster. Here is the main layout. Okay. Control of the left, map on the right. Really? No. It's possible to configure the demo absolutely. Change the colors, okay, change the position, right, top, down. It's possible resets, and the map is updated. Okay, we have integrate the Mapbox API. For example, this API is isochron API. On click, you can change in real time the isochron API. It's possible to configure driving, walking, change meter, distances, 15 minutos agree. It's possible lines, polygons. It's possible multi-stores, multi-isochrons. It's good, for example, for multiple stores. It's possible connect to Overpass API. Okay, when you click and share the API, the OpenStreetMap, can you see, for example, the 10 seconds more or less, possible to see the building in the isochrons. It's possible to update the data, and you click, you see more data, right? Okay, yes, you can see more data. Other, for example, delete, clear, and delete. For example, direction, when you click in the map, in real time direction, it's possible update the data, right? In car, road. Others, for example, type query, can you see information in a radius, right? Matrix, for example, this is the center, and you click, 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 fetch the data in real time, and you see the information. If you don't like the map, you can change the base map, click, and see better information in that map, all right? Other, for example, static estimations, geocoding, forward, reverse, edit the standard style. For example, this is the new standard style. You can edit. It's possible. For example, we have a demo. If you like to work to test the building, this is a different examples. Possible see the map, right? For example, for tree building, activate the draft application and model. Okay. If you like, for example, in Barcelona, right? For example, drive a little building, a polygon. When you click, and click, it's possible. Finish the click. Okay. Pull up after the model. And in real time, you can scale the model, scale X, Z, and rotation. For example, this and this. If you don't like this, you can change this, for example. And you can see the information in real time. If you don't like the map, you prefer see in dark, it's possible. See the information in dark, see the 3D model in dark and change and only see the information. If you like to see the histogram, can you click? Okay, it's maybe click, and you see the information in real time. If you like, for example, pull up a data, add JSON layer, select files, and it's possible to pull up a JSON file. For example, opportunities map. Open, and you see the information in real time, opportunities map. For example, this is a information hexagon data. Can you see the information? Can you read information? Open, see. This is okay, This is a multiple function of the DEME. And okay, resets. And we have a multiple samples, and you see multiple samples, highlight filter, cluster, side by side, model, satellites in real time, head maps. See, this demo is prepared to start a Mapbox application faster. Okay. Thank you. Thank you very much.
All right, thank you, Javier. This is amazing, very complex UI, very good design styling, and also yes, lots of spatial functionality happening. So feel free to ask your questions to Javier, and thank you for presenting. Next, I would like to welcome Noe Garcia as a transportation planner at Arcadis, and he's going to show us how he's building AI agents to do spatial analysis using Mapbox tools. Take it away, Noe.
Hello, everyone. Can you hear me? Okay, well, thanks. First of all, for the space. Well, the idea of this project is to get an option for spatial data analysis or data visualization, and as well as a complement of the dashboards. Because the idea is that the most natural way to communicate is through the dialogue. However, sometimes in the dashboard visualization we have complex panels. We are probably only interested in one question, and we want the easiest way to ask ourselves that. So the easiest way is only with a question. And in this example, we have only at the top, and we have some example of what we can speak directly with the data. But as well, these contain events related with the Mexico City. But first of all, I would like some questions or some instruction, like show me, even if I wrong in the writing, the model can understand. Show me a map from Mexico City. So the model can show me a map that we can see the Mexico City. So the idea is to integrate spatial data analysis through these, for example, events through a natural language, and we can see immediately the results. So other way that I'm going to copy and paste this example for people. Show me the route by walking cycle from Centro Histórico to Ciudad Universitaria. And this is really interesting because have three characteristics. The first one, Centro Histórico, Ciudad Universitaria need to be converted into coordinates. So here we are using the geocoding and from Mapbox, and as well I am using the geocoding from get the route from this point. So you have to process geocoding and then the routing. But that is an example. No, only I put the route, walking, cycle, and car, and here are the results with the time. Other example is like now from Ciudad Universitaria, show me a map with isochrone. Maybe if I have some is wrong this word, the model can understand. By 5, 10, 15 minutes walking. So here I request a map, and the result is going to be in this way. The idea is that you can continue with the conversation as well, requiring some spatial operation from this polygon. And now from that polygon, show me the events that are inside. So that is a spatial operation that related with intersection or spatial joints. So the next result can be the events that are inside. And as well, I only with this is a natural language and can convert it into a spatial operation like this spatial joint and create the isochrones. Other way, now show me, well, maybe you can request for change the color, but that is not interesting. So the idea is that when this kind of queries or requests, the model can turn into coding into coordinates and call the Mapbox API forget the isochrones, the routing on the coding positions. And this is, well, an easy way to convert. Maybe we can be, only can generate maps. No, we can request like, well, now show me a table with the first 10 rows. Well, the table is that are inside of the model, but the most interesting is that we can do that kind of data visualization. I'm going to create other one, like show me a heat map with all the events. And as you can see, I request here, and then the model can provide me the results in a fast way. But another example could be now from center of Mexico City create a buffer by meters in a map. So that is other spatial operation because requested from geocoding as well as spatial projection. And then the other one is now, if I am okay with the position, I could say now with that polygon, show me the events that are inside. Please. We have the polygon, we have the result, and as well we can see the no. As you can see, it's really easy to speak with that. I am using a Mapbox from this the API from pre-coding from the root, but as well I am using a library called Mapbox API from the author is Walker. So it's an easy way to call all this process like a Mapbox API, get an isochron, and first get the coordinate, and then this converted into a polygon. So that is the idea of the project, that is to try to implement as a complement of data visualization of dashboard. Well, that is all my presentation. If you have some questions, that is my email, start.log@gmail.com or Osorio@cmap. So that is, if you have a question, please put it in the comments. And thanks for the space, and thanks for Mapbox for this opportunity.
Excellent. Thank you, Noe. That was wonderful. And yeah, be sure to drop those questions in the chat. And we're going to move on to our last, maybe second to last presentation. This one's going to be pre-recorded, so give me just a moment to queue up that video. So this video is from Taichi Kojima. He's going to be talking about reviving Mapbox for Unity for a project. So let's talk about Mapbox for Unity.
Hello everyone, my name is Taiki Kojima. Today I'm going to share my experience reviving Mapbox for Unity to build a lightweight city flight simulator over Okazaki City in Japan. Okazaki is located in the very center of Japan, halfway between Tokyo and Kyoto, and is best known as the birthplace of Tokugawa Ieyasu, known as first shogun. Around January 2025, I often heard about Plato, Japan's government-led 3D mapping project. It even had Unity integration, but on a low-spec PC, it was slow and lacked detail for small cities like Okazaki. I checked Google's services. Integration had ended. Sessin was a successor, but still not ideal. Then I found Mapbox for Unity. Development had stopped, but the 2020 YouTube video gave me the key to bring it back. To revive Mapbox for Unity, I had to overcome 4 challenges. First, installing the SDK. The Mapbox setup menu didn't appear until I deleted extra folders. Second, the collider bug. Players could walk through buildings. Third, the POI dropdown was missing in Map Inspector. And fourth, the game controller's camera stayed locked to compass directions, not the current view. For the install issue, deleting Unity AR interface, Google AR Core, and Mapbox AR fixed it. For the collider bug, I followed online tips and copied updated scripts from GitHub, and it worked. For the POI issue, the dropdown was missing entirely. I had to create my own workaround to enable POI display. I wanted full game controller support. Right stick for pitch and roll, left stick for throttle and yaw. But just writing a C# script wasn't enough. I had to build a Unity input system to pass stick movement into the simulation. After many tries, it worked, but the camera still stayed fixed to compass directions. But it's probably a Unity setup issue, and I'd welcome help. By switching Accent option to range around transform, the map keeps loading ahead of the player. You can literally fly to the end of the earth. And I think the moderate detail level in Mapbox actually makes it more fun, leaving room for imagination and memories. Recently, Mapbox republished the Unity SDK docs. It's still alive. I realized it in this August, not seen in March. There, the install issue is officially fixed. The collider bug still needs a manual fix. The POI dropdown still missing. Pricing still unclear. But Mapbox for Unity remains valuable, especially for beginners, tourists, and education. Thank you for listening. I hope you try it yourself.
Thank you so much for that. I'm going to share one last thing very briefly, and this is a side project of mine. So give me just a moment to cue that up. All right, so this is a fun little side project that I did a few months ago, actually. So I'm going to start by showing you this, which is Azgaar's fantasy map generator. So this makes fantasy maps, not something I'm particularly interested in, but I do love the fact that it's all procedural. So every time you reload this site, you get a whole new map. So it's generating, it's got a whole algorithm that's used in video games and things like that for generating coastlines and generating rivers. And I was wondering what it would take to port this over to Mapbox GL JS. And I did it. So here it is in Mapbox GL JS. So if you reload, each time you're going to get a new map. And now Because it's not rendering an SVG like the original, it's actually a lot more performant and smooth. And you can zoom in, you can see all these little cities and trails and things like that. Mostly, I would say this was like an exercise in hijacking the code. So I'm going to say thank you for the original Azgaar who made this fantasy map generator for making it all open source and putting everything on the internet. I was able to parse through a lot of JavaScript and figure out the exact right spots to hijack the SVG code and do coordinate transformations to get them into a coordinate reference system that would work with Mapbox GL JS. So it was mostly hijacking SVGs, converting them into geojson, and then copying a little bit of the styling, or sort of hijacking some of the styling to work with Mapbox style spec. So every time I hit reload, we're generating a new map. I'm going to publish this on GitHub. I don't really have any serious plans for it. I just thought it was kind of fun. So thought you might be interested in that. Thank you to everyone else who presented during this show and tell. Love to see the variety of use cases and all the interesting passion projects that everyone has put their blood, sweat, and tears into. And thank you for building with Mapbox and sharing your creations here. Thanks for joining, and we'll see you later.